Hi guys, welcome back. We're going to continue talking about greatest common factors a little bit differently today. So go ahead and tell me, what is the greatest common factor? The greatest common factor is the largest, let's write correctly here, the largest number and or variable that goes into or is divisible into all the terms, okay? And the reason we need greatest common factor is we need a way to undo distribution. So remember, when we have like 4 times x squared plus 2x plus 5, we go, well, 4 times x squared is 4x squared, 4 times 2x is 8x, and 4 times 5 is 20. So we need a way to be able to undo that, and we do that with greatest common factor. So if I look at this, we're going to factor each polynomial, find the GCF of all the terms, and then you write it on the outside of the parentheses. What's left goes inside the parentheses. And you did this a little bit in Math 7. So I'm looking at the greatest common factor between these. So if I look at just the numbers, or just the coefficients, the greatest common factor of those is 2, because 2 will go into each term. There's not an x in every term, so I can't factor out an x. So then I'm going to go ahead and say, well, 2 goes into 4 2 times, and the x squared comes along for the ride. 2 goes into 2 one time, so I'm just left with x, and 2 goes into 2 one time. Okay, and again, I could be like, well, 2 times 2x squared is 4x squared, 2 times x is 2x, and 2 times negative 1 is minus 2. So you can always check your work on this. So if I look at this one, if I look at the coefficients, there's not anything in common with 4 and 3. So the greatest common factor would be 1 there. But then if I look at my x's, there's an x in both terms. Okay, so I can factor out an x. And so then I'm left with 4x, because if I divide this by x, x squared divided by x is x to the 1. And then if I divide this by x, I'm just left with my minus 3, because the x's will cancel out. Okay. Here, remember, this would be x times x, so just one of them cancels out, which is why we're just left with the x there. Okay? All right. Let's try another one. Go ahead, why don't you try this one? So I'm looking at my 3 terms here, and I see that my coefficients are 10, 20, and 5. So I can pull a 5 out of all of those terms. I also see that we have an x in every term. Again, if this had been like an x squared here, we would have pulled out an x squared, because that would have been the lowest exponent like we talked about yesterday. And so if I divide each piece by 5x, well, 10 divided by 5 is 2. X cubed divided by x is x squared. Plus 20 divided by 5 is 4. X squared divided by x is x. And then 5x divided by 5x is 1. Okay? So if the greatest common factor is everything of a piece, you have to put the 1 there as a placeholder, because otherwise if you multiplied there we wouldn't get the 5x. So we have to have the 1 there as a placeholder. All right, now this one, if I look at this, I can see that they both have a negative or a minus. So I definitely want to factor out that negative. It'll help me in the long run. And then the greatest common factor between 12 and 8 is 4. And then I notice that there's an x in both of them. So I'm going to divide all of this by negative 4x. Well, negative divided by negative becomes a positive, and then 12 divided by 4 is 3, and the x disappears because there's just 1 on top, 1 on bottom. Negative divided by negative is also a positive, so it's going to be plus 8 divided by 4 is 2. X squared divided by x is x. And again, we're using our exponent rules to get that, because 2 minus 1 is 1. So that's where we're getting that from, in case you're wondering. So just like we did over here, x cubed over x is 3 minus 1, which gives us 2. Okay. All right, I believe that, sometimes it's helpful to factor out a negative. And I believe that's it for today. Have a wonderful day, and we'll talk to you later. Bye.